Continuing on the next page of the Chapter 7 practice test for geometry, we're looking at number 10 here, where we have a proportion set up, so we want to do the cross product. We're going to multiply 5 times b minus 5, set that equal to the other cross is 2 times 2. So on the left we need to distribute 5b minus 25 equals 4. Add the 25 to both sides, and we get 5b equals 29. So when we divide both sides by 5, we get b equals 5.8. Number 11, same thing, but this time we're going to have variables on both sides. So when we multiply this diagonal and this diagonal, we're going to have to distribute on both sides. So 5 times v plus 10, set that equal to 7 times v plus 5, and draw lots of rainbows to show distributive on both sides. So 5 times v is 5v, 5 times 10 is 50, 7 times v is 7v, and 7 times 5 is 35. Since 5v is smaller, I'm going to subtract that from both sides and subtract 35 in the same step. These are opposites, so we're left with 2v equal to 15. Divide both sides by 2, and we get v equals 7.5. Number 12, we want to see or state if these two polygons are similar. So in order for two polygons to be similar, they need to have all their angles congruent. So in the first figure, we have 1, 2, 3, 4 little boxes, which means 90 degrees. And on the second figure, we have the same thing. So are they all congruent? Yes, they are. They're all 90 degrees. So they're definitely all congruent. Then we need to check the sides and see if the sides are not congruent, but proportional, if they have the same ratio. Okay? So I'm going to do this side to this side, which is 30 to 25, and reduce it. That reduces all the way to 6/5. Then I'm going to do this side to this side, which is 36 to 30. We should get the same ratio when we reduce it, and we do. We get 6/5 as well. So we say, yes, they are definitely similar. Then we jump over to number 13, and we want to know, are they similar? So the first thing we do is check the angles. So we have these two angles congruent to these two angles, and these two angles congruent to these two angles. So the angles are good to go. Then we just need to check the sides to see if they're in the same ratio. So I'm going to take the 20 to the 23, and divide them both by 4. That reduces to 5 over 5.75. The same thing should happen when I do the left side to the left side. So if I take 14.5 over 18.8, I'm going to get some crazy number. So let's try the bottoms, 30 to 36. This one, when we divide both by 6, we get 5 over 6. And if you compare these two ratios, they are not the same. So no, they are not similar. Jumping down to number 14. It says to solve for x, and it tells you that the polygons in each pair are similar. Okay? So we should be able to match up the sides and get the same ratio. So if the top on this one is 15, to the bottom, or to the side on this one is 10, that'll be my ratio on the left. I need to use the same two sides on the bottom triangle. So I've got 9 over 2x minus 18. This number right here is extra. You don't really need it. Okay, now we're going to do our cross product. So we're going to have 15 times 2x minus 18. Set that equal to 10 times 9. So I need to distribute on the left here. 15 times 2x is 30x. 15 times negative 18 is negative 270. And 10 times 90 is 900. Oh, it should just be 10 times 9, so it should just be 90, sorry. All right, now we add 270 to both sides. And we get 30x is equal to 360. So when we divide both sides by 30, we get x equals 12. Number 15, same thing. You need to match up the sides that are corresponding. So I'm going to do the top and the left side, the top and the left side. So x minus 5 over 3, set that equal to 8 over 6. And then do the cross product. So I'm going to do 6 times x minus 5, set that equal to 3 times 8, which is 24. And then on the left, I need to distribute. 6 times x is 6x. 6 times negative 5 is negative 30. Add that 30. So 6x is equal to 54. And when we divide both sides by 6, we get x equals 9. Jump down to number 16. State if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. So on number 16, we have some sides that match up. We'll need to check and make sure they're in the same ratio in just a second. But we also need to have a pair of angles. Well, the way these are drawn, you have this x right here, which makes these vertical. And vertical angles are always congruent. So we have a pair of angles here and here that are congruent to each other. Now these triangles are flipped from each other. So this one is going to correspond to this one, and this one is going to correspond to this one. So we're going to say 21 to 49 is equal to 12 to 28. We're going to do their cross product and see if it's true. So 21 times 28, set that equal to 12 times 49. Get out our calculator, punch some numbers in. You should get 588 on the left. You should get 588 on the right. And so you'll say, yes, they are similar. And then the similarity statement is going to be that the triangle KLM is similar, this little symbol is similar, not congruent, to triangle KQR. Notice that they're flipped. And the reason is by side, angle, side similarity. All right, when you jump over to number 17, right away, you're going to notice that this angle is 31 degrees and this angle is 32 degrees. So no, they are not similar. Pretty easy to tell, and you can stop the problem there. Turn the page over to number 18. Number 18, we've also got another pair of vertical angles. We've got this angle and this angle congruent to each other. So we can say that these two are similar by angle-angle similarity. All you need is two angles. That's one easy way. So triangle FGH is similar to triangle FKL by angle-angle similarity. Number 19. We've got our sides labeled on both triangles, so we need to see if they're similar by side-side-side similarity. So we need to see if all the ratios are the same. So we're going to take the side over here to this side over here. So I'm going to take 48 to 8 and reduce it, which is 6 to 1. Then I'm going to do the right side, the 54 to the 9 and reduce it, which is 6 to 1. So far, so good, right? Let's do the bottom. 60 to 10 obviously reduces to 6 to 1, so you say yes. They are similar by side-side-side similarity. And triangle TSR, they went this direction. So we want to go to the same direction, LMN. Number 20. We just need to solve for x. So you can draw an imaginary line down the middle here. That creates a left side and a right side, a numerator and a denominator, a numerator and a denominator. So you can easily set up a proportion, do the cross product, and solve. I like to go this way first, so 5x equals this way, 10 times 2. So 5x equals 20. Divide both sides by 5, and you should get x equals 4. Number 21. This one's a little bit trickier because instead of giving you this piece and this piece, it gives you the length of the whole thing. So just this part down here is 15 minus 2x minus 9, which is actually 15 minus 2x plus 9, once you distribute that negative sign, which is 24 minus 2x. So this little piece right here is 24 minus 2x. This side's a little bit easier because 10 minus 6 is just 4. Now we can use our imaginary line and do our left and right, numerator, denominator, and set up our proportion. So 2x minus 9 over 24 minus 2x, set that equal to 6 over 4, and do the cross product. So we're going to have 4 times 2x minus 9, set that equal to 6 times 24 minus 2x, and distribute on both sides. It's a lot of rainbows to draw. So 4 times 2x is 8x, 4 times negative 9 is negative 36. 6 times 24 is, what was that, 144. And 6 times negative 2x is negative 12x. So I'm going to add 12x to both sides. In the same step, I'm going to add 36 to both sides. That leaves me with 20x equal to 180. Divide both sides by 20. I got x equals 9. Number 22. Seems easy after number 21. Draw your imaginary line, create your left and right, and then set up your proportion. 12 over 2x plus 3 equals 8 over 10. So the cross product will be 8 times 2x plus 3. Set that equal to this diagonal, 12 times 10. Distribute on the left. So you have 16x plus 24 equals 120. Subtract the 24 from both sides. So 16x is equal to, what is that, 96? Divide both sides by 16 and you get x equals 6. Number 23. You got to do a little subtraction over here too because they give you the whole length of 20. So you need to subtract that 12 to get that 8. And then there's your imaginary line. So you have your left and right and numerator and denominator. So 8 over 12 sets up your left side of your proportion. And 10 over 4x minus 5 sets up the right side of your proportion. And do your cross product. So 8 times 4x minus 5 on the left, 12 times 10 on the right. Do your distributing over here. You should get 32x minus 40 equals 120. Add that 40 to both sides, so you get 32x equals 160. And then divide both sides by 32, so you should get x equals 5. Number 24. This one is set up nice and golden for you. Here's your left and right, numerator and denominator. So set up your proportion, 20 over 2x minus 12. Set that equal to 15 over 6. And do your cross product. So you'll have 15 times 2x minus 12. Set that equal to 6 times 20. And distribute on the left. So you're going to have 15 times 2x, which is 30x. And 15 times negative 12, which is negative 180. So that equals 100. 6 times 20 should be 120. Add that 180 to both sides, so you get 30x equals 300. So divide both sides by 30 and you get x equals 10. Number 25. I'm almost out of recording time, so here are the last 3 answers. If you need help setting them up or solving them, let me know. Thanks for watching.